hello, good morning everyone. Our topic for today is all about conservation of energy. So energy is defined as the capacity of a given body to produce physical effects or work external to the body. So the unit associated with energy is joule or Newton meter or foot pounds. So under energy, meron tayong first law of thermodynamics. So sabi dyan, energy cannot be created nor destroyed. It can be only transformed from one form to another. So hindi natin kinecreate or nade-destroy ang energy. Energy can only be transformed from one form to another. So meron tayong iba't ibang forms of energy. First is the stored energy. Energy stored within the body which goes or dependent upon the flow of the mass. Stored energy can have many forms including potential energy, kinetic energy, internal energy, and flow work. Okay? So, doon muna tayo sa different forms of stored energy. So, unang-una dyan is the potential energy. So, kapag sinabi natin potential energy, stored energy due to its elevation above any arbitrary datum plane. Okay? So, kapag potential energy, meron tayong mass, then meron tayong height. So, sinusukat natin yung energy due to its elevation. So, ang formula niyan is mass times gravity times height or force times the height or datum, height niya mula sa datum. So, kapag change in potential energy, ang formula natin is M times gravity observed divided by the gravity constant or gravitational constant times the delta C or change in height natin. So, equal siya sa mgo over gc times C2 minus C1. So, final height minus the initial height. Or pwede rin siya in terms of P2 minus PE1. Okay? Where M natin is the mass, height is h, g is gravity, and c is the elevation from the reference datum in terms of meters or feet. The next type of stored energy is the kinetic energy. So kinetic energy is the stored energy of a body by virtue of its motion or velocity. So check natin yung kaibahan ng potential energy doon sa ating kinetic energy. So kapag sinabi natin potential, ito yung stored energy natin due to its elevation. So kapag hindi mo pa siya, like for example, meron kang bola, hindi mo pa siya ginagalaw, ang tawag dyan ay stored energy. Pero once na tinulak mo yung bola, okay? So, yung bola magkakaroon niya ng velocity, yan ay yung tinatawag natin na kinetic energy. So, the formula for kinetic energy is 1/2 mv squared or sa atin is mv squared over 2gc, where v is the velocity, m is the mass, and gc is the gravitational constant. So, kapag change in kinetic energy, we have delta KE yan mv2 squared minus p1 squared over 2gc. Or, pwede rin siyang ke2 minus ke1. Okay? So, ayun nga, gc is the gravitational constant. p1 is the initial velocity. Pwede siyang SI in terms of meters per second or English in feet per second. v2 is the final velocity. Pwede siyang in meters per second or feet per second naman kapag English. Okay? So, next is the internal energy. So, kapag sinabi natin internal energy, stored energy due to its motion of molecules and forces of walang phases. Due to the stored energy due to its motion of molecules and forces of attraction between them. Okay? Parahin ko lang to. Okay, so para maintindihan natin yung internal energy, let's say mag-drawing tayo ng isang object. So sa object, meron yung molecule sa loob. Okay? So, kapag nag-apply tayo ng heat, so Q is the heat, then meron tayong initial temperature. Kapag nag-apply tayo ng heat dyan, yung molecules natin sa loob, lumilikot yan. Okay? So, yung motion ng molecule natin dyan, yung paglikot ng molecule natin dyan, yan yung ating sinusukat na internal energy. Okay? So, syempre, pag nag-apply ka ng heat, tataas yung temperature. So, magiging temperature 2 na siya. So, the formula for internal energy is mCv delta T. Okay? Yung CV natin is specific heat of air due to constant volume. Okay? So, air dapat CV. So, kapag delta T, delta U, pwede rin siyang i-write as mCv T2 minus T1 or the final temperature minus the initial temperature. Pwede rin siyang i-write as delta U is equals to U2 minus U1, where CV is the specific heat of air due to a constant volume. So, meron tayong standard value niyan, ano? Yung CB. Delta T is the temperature difference. And yung CB natin, dalawa yan, either SI or English. So kapag SI, CB natin is 0.7186 kilojoules per kilogram. Kapag English, ang CB natin is 0.171 BTU per pound degree Rankine. The next type of stored energy is the flow work. The flow work is the work or energy needed to push the fluid into or out of the boundaries of a controlled volume. If mass flow is involved, flow work is necessary for maintaining a continuous flow through a controlled volume or open system. So let's say meron tayong system. So let's say sa system natin may papasok na M1, pressure 1, and specific volume 1. So dapat yung lalabas dyan ay equal lang. Parang yung conservation of mass natin, no? So lalabas dyan is M2, P2, and P2. So para ma-derive natin yung formula ng ating flow work, so since ang nomenclature natin, yung mga variables natin doon ay mass, pressure, and volume, gagamitin natin yung conservation of mass natin na topic yung last lecture, where mass in is equals to mass out. Okay? So therefore, workflow is mass times change in pressure times change in volume. So yung volume, pwede mo siyang i-write in terms of area times length. Okay? So, pwede rin siyang i-write as M P2V2 minus P1V1. Or since PV is equals to MRT, pwede natin siyang i-write as MR delta T or MRT2 minus T1. So, now let's proceed to the work done by a closed non-flow system. So, let's say ito yung ating piston. So, ito yung kanyang initial position. Ito. Yan. Then, ito yung kanyang final position. Ito yung ating piston rod. So, sa piston rod, meron tayong tinatawag na diameter. So, makukuha natin yung area ng ating piston rod. Then, pwede rin natin makuha yung area ng ating piston by using the diameter of the cylinder. Okay, so kapag nilagay natin siya sa PB plane or PB diagram, ito yung magiging itsura niya. So, from initial 1, ganyan yung kanyang ito yung kanyang point. Then, and nag-expand siya. Ito na yung magiging kanyang point 2. So, doon sa ating expansion ng piston rod, meron tayong change in volume and change in the work. Okay? So, ito ang kanyang V2 and ito ang kanyang V1. So, from the diagram, since meron tayong dV, dW, and pressure, pwede nating i-write yung formula ng work as integral of P dV. Okay? So, kasi ang volume natin ay nabago. So, limits from 1 to 2. So, from point 1 to point 2. Where A is the area of piston, pwede siyang in terms of meter squared or feet squared. P is the pressure in terms of PSI or kilopascal. And R is the gas constant. So, meron tayong gas constant na tinatawag. So, sa air, kapag SI yung ating gas constant, it is equivalent to 0.287 kilojoules per kilogram Kelvin. Kapag English naman, 53.34 foot-pounds per pound mass degree Rankine, and L is the length of stroke. Okay, so yung haba ng stroke ng piston natin, yan yung tinatawag na L. Then, take note kapag work done by the system, positive yan. Kasi yung system mo yung nag-produce ng work. Then, work done on the system, sabihin, naglagay ka ng work sa system, negative yan. Okay? So, pakitandaan na lang yung mga sign na yan. Kasi gagamitin natin yan kapag nag-solve na tayo ng mga problem. Then, punta tayo sa second form of energy, which is the transition energy. So, kapag sinabi nating transition energy, energy that is in transit or on move, which are not dependent upon the flow of mass. So, ito yung energy na gumagalaw or on move. So, hindi siya nakadepende sa flow ng mass natin. So, first example ng transition energy is the heat. Heat is the energy in transition between a system and its surrounding due to the temperature difference between them. Temperature difference. Yeah. So, sa heat, meron tayong dalawang klase. So, ang dalawang klase ng heat natin ay sensible heat and next is the latent heat. So, kapag sinabi nating sensible heat, it is the heat needed to change the temperature of the body without changing its phase. So, nagbabago ang kaniyang temperatura without changing its phase. Then, opposite dun sa ating latent. So, kapag latent naman, nagbabago naman yung kanyang phase without changing its temperature. So, to elaborate more itong ating sensible heat and latent heat. So, meron tayong example dito. So, meron tayong ice from negative 10 degrees Celsius to 110 degrees Celsius. So, by definition, sensible heat, nagbabago yung temperature nang hindi nagbabago yung phase. Ano ba yung phase natin? Ang phase natin is solid, liquid, and gas. Yung pang-apat pa nga is plasma. Then, temperature, of course, ayan. Then, let's say meron tayong temperature of negative 10 degrees Celsius ng ice. Gawin natin siyang 110 degrees Celsius of steam. So, yung first condition natin, ice, kasi kapag yung ice naman, hindi naman agad-agad magiging steam yan. No? So, yung ice mo, magiging water muna yan bago maging steam. Okay? So, from negative 10 degrees Celsius, bababa ang temperature niyan into 0 degrees. Therefore, sensible heat yan. Kasi ang phase mo ay ice pa rin. So, ice to, ice pa rin yan. So, ang tawag yan, sensible heat. Yung phase mo hindi na bago, pero yung temperature mo na bago. Then, kapag naging 0 degrees na siya, magbabago na yung phase niya. So, magiging water na siya, pero yung kanyang temperature hindi mababago. So, ang tawag naman dyan is latent heat. So, nabago yung phase from ice to water, pero yung temperature hindi na bago. Then from 0 degrees, magiging 100 degrees kapag pinakuluan mo. So nabago yung temperature pero tubig pa rin siya. Ang tawag naman dyan ay sensible heat. Then from 100 degrees of water, naging 100 degrees ng steam. Therefore, ang tawag naman dyan is latent heat. Kasi temperature mo is the same pa rin, parehas 100, pero yung phase niya, naging steam na siya. So, nabago yung phase mo. Then last, 100 degrees Celsius to 110 degrees Celsius of steam. Nabago yung temperature, pero yung phase niya, steam pa rin. Yan ang tinatawag natin na sensible heat. So, that's the difference between the sensible heat and the latent heat. So, ang formula natin for sensible heat is mCV delta T. Or MC delta T lang, no? Ang C kasi nakadepende kung constant volume or constant pressure. So, kapag constant volume, ayun yung gagamitin natin, MC delta T. Kapag constant pressure, MCP delta T. Depende sa problem natin. Pero ang pinaka-general formula niyan is MC delta T, where QS is the sensible heat, mass is the M, C is the specific heat, and delta T is the change in temperature. So sa water, meron tayong tinatawag na specific heat or meron tayong constant for specific heat. So specific heat of water in terms of kilocalories, it is equals to 1 kilocalories per kilogram Kelvin. Kapag SI, 4.187 kilojoules per kilogram Kelvin. Kapag English naman is 1 BTU per pound degree Runtime. Then latent heat, ang formula lang natin ng latent heat is mass times L. Yung L is the latent heat of fusion or vaporization. So dalawa yan. QL is latent heat, M is mass. So kapag LF, latent heat of fusion. Kapag LV, latent heat of vaporization. So meron tayong constant for LF. So kapag mag-freeze tayo from water to ice, ang gagamitin natin na L is the latent heat of fusion. Okay? So from tubig to ice, latent heat of fusion. So ang constant na value niyan is 144 BTU per pound or 335 kilojoules per kilogram kapag SI. Then kapag magpapakulo naman tayo from water to steam, ang ginagamit natin is the latent heat of vaporization. So ang value niyan or ang constant value niyan is 970 BTU per pound or kapag SI, 2257 kilojoules per kilogram. So ayan, applicable lang yan sa water. Okay? So take note that heat is positive or Q is positive when heat is added to the body or system. So kabaliktaran ng work natin kanina. So kapag heat naman, kapag naglagay ka sa body or sa system natin, positive yung heat natin. Then kapag nag-reject ka, na nilabas mo yung heat, negative yung sign natin. Okay? So next type of transition energy is the mechanical work or power. So formula ng power is 2 pi Tn over 60, where T mo is the torque, pwede siyang foot-pounds or Newton meter, N is the rotative speed or RPM, kaya siya naging over 60 kasi ang speed natin, kalimitan, mostly is RPM. Okay? Then P is the power, pwede siyang HP or kilowatts. So, more on cancellation of units lang naman ito. Okay? So, kaya siya over 60 kasi yung speed natin is in terms of RPM. Then, let's talk about the energy diagram of a steady flow system. So, ito yung diagram natin. May pumasok na potential energy 1, may pumasok na kinetic energy 1, may papasok na P1, B1 or workflow, may papasok na internal energy 1. So, tas meron tayong datum level. So, from this datum hanggang dito, yan yung ating tinatawag na C1 or height 1. Then, meron tayong pumasok na heat and lumabas na work. So, palabas yung P2, K2, P2, V2, and U2. Then, meron din tayong datum height na mula dito sa datum level hanggang dito sa point na to. So, yan yung ating C2. So, yung formula natin dyan, kapag i-derive natin, kailangan the energy entering the system must be equal to the energy leaving the system. So, ano ba yung mga papasok? PE1, KE1, U1, workflow 1 or yung ating P1B1, ito. Then, yung heat. Okay? Then, equal siya sa mga lalabas, which is PE2, KE2, workflow 2 or P2V2, U2, and work steady flow. Yan. Okay? So, para ma-derive natin yung formula ng heat in terms of the steady flow system, ililipat natin tong PE1 sa kabila. So, magiging minus yan, ano? PE2 minus PE1. Diba kanina yung discussion natin ng potential energy? Delta PE is equals to PE2 minus PE1. Same lang din doon sa iba. Okay? Pag nilipat natin yan, magiging PE2 minus PE1 or delta PE. So, kapag ito nilipat natin sa kabila, magiging KE2 minus KE1 or delta KE. Kapag ito nilipat natin dito sa kabila, magiging U2 minus U1 or delta U. Kapag ito, workflow 1, nilipat natin sa kabila, workflow 2 minus workflow 1 is delta workflow. Then, copy mo yung work steady flow. So, yan na yung formula natin of heat in terms of steady flow system. Then, next is the enthalpy. Enthalpy is a composite property applicable to all fluids and defined by H is equals to U plus PV. So, enthalpy, tinatawag din siya combination energy. So, combination siya ng internal energy plus the workflow. So, from the formula of heat kanina na na-derive natin, delta PE plus delta KE plus delta workflow plus delta U plus work steady flow. Where ito, yung workflow plus delta U is equals to delta H. Therefore, heat is equals to delta PE plus delta KE plus delta H plus work steady flow. So, kung negligable naman to sa problem, yung PE natin and KE, therefore, ang formula ng heat natin is work steady flow plus delta U. Okay? So, that's all for our introduction sa ating conservation of energy. So, kung meron tayong tanong, paki-message na lang sa Messenger. So, thank you, stay safe, and God bless.